Hey everyone, this is Andrew, and I'm a software engineer and tech lead for companies in Silicon Valley like LinkedIn, Microsoft, Snapchat, IBM, BlackBerry, and I will be your instructor for the course, Software Engineering Interview Prep. If you're targeting software engineering role at top tech companies, I would highly recommend you attend this course. This course is absolutely for free, and we will cover everything from software engineering to technical interviews to go-to-market strategy. And during this course, I will cover important topics, most asked interview questions, and the most efficient ways to solve them. And I have more than 7 years of experience in software engineering role at top tech companies in the United States. And I have helped a lot of candidates with interview preparation. I'm excited to help you land your dream role. So sign up for my course, and I look forward to meeting you in the sessions. So let me give you a quick intro and overview of HiCounselor. So HiCounselor is an online career accelerator which helps job seekers find a full-time job. HiCounselor helps candidates with interview prep as well as getting the interview calls. So we utilize AI-powered job search tool and strong network of 300 plus employers to help candidates land a job. So every candidate gets personal attention and mentorship from professionals like myself who come from the top tech companies. The payment structure at HiCounselor is income share agreement where you don't have to pay anything to HiCounselor until you land a job. So once you find a job, you pay a small fraction of your salary in monthly installments. So there's $0 upfront payment. If you are currently looking for a job, HiCounselor could be an amazing resource for you. And the next cohort at HiCounselor starts very soon. So if you're interested, please apply on HiCounselor.com. Feel free to use my code Andrew, and you will get a $500 discount when you start paying HiCounselor after landing the job. Okay, so in this session, we're going to study recursion. So we'll go over the overview and the use cases as well as how these are applied to real world problems. And then we'll solve 3 to 4 questions together. And then I'll also give you some amazing educational questions that you can solve on your own at home. So let's go over, let's study recursion. So what is recursion? So recursion means defining a problem in terms of itself, right? So this is very powerful in writing algorithms because recursion comes directly from mathematics, where there are many examples of expressions written in terms of themselves. For example, if you look at Fibonacci sequence, you realize it's written as this. So recursion is a process of defining a problem in terms of a simpler version of itself. For example, we can define an operation, find your way home, as if you're at home, stop moving, take 1 step toward home, and find your way home. So here, the solution to finding your way home is 2 steps or 3 steps. First, we don't go home if we already are home. Secondly, we do a very simple action that makes our situation simpler to solve. Finally, we redo the entire algorithm. So here's an example of recursion that would be for finding value in a list of numbers. So the maximum value in a list is either the first number or the biggest of the remaining numbers, right? Again, the maximum value in a list is either the first number or the biggest of the remaining numbers. So here's how we would write the pseudocode of the algorithm. So this is an example of how it would look like if we're trying to find the maximum value in a list of numbers. The maximum value in a list is either the first number or the biggest of the remainder of the numbers. So there are parts of recursive algorithm. All recursive algorithms must have base case, when to stop, work towards the base case, and number 3, recursive call. So the work towards the base case is where we make the problem simpler. For example, divide the list into 2 parts, each smaller than the original. And the recursive call is where we use the same algorithm to solve a simpler version of the problem. The base case is the solution to the simplest possible problem. For example, the base case in the problem, find the largest number in a list, would be if the list had only one number, right? And by definition, if there is only one number, it's the largest value. So again, it's a process in which function calls itself directly or indirectly, and the corresponding function is called as a recursive function. All right, so so how a particular problem can be solved using recursion? So the idea is to represent a problem in terms of one or multiple smaller problems and add one or more base conditions that stop the recursion under a certain condition. For instance, we compute the factorial n if we know factorial of n minus 1. The base case for factorial would be n equals 0, and we return 1 when n equals 0. So you might have noticed that what if there is a stack overflow when we're doing recursion? So if the base case is not defined, then the stack overflow might arise. So let's take a look example of this. Let's look at an example. If you have a method with wrong base case, which might cause stack overflow. So if n equals 10, we return 1. And then else, we return n times fact n minus 1. Right? So if we call fact of 10, it will call fact 9, 8, 7, and so on. But the number will never reach 100, which is this statement. Again, so if the fact 10 is called, it's going to call fact 9, fact 8, fact 7, and so on. But that particular number will never reach 100. So we have the wrong base case, which causes stack overflow. Base case is not reached. And if the memory is exhausted by these functions on the stack, that's going to cause stack overflow error. So what is the difference between direct and indirect recursion? So function is called direct or recursive if it calls the same function itself. So let's say you have a function called, a function. A function is called indirect recursive if it calls another function, say function 2 or function 3. And that calls the other function indirectly. So the difference between direct and indirect recursion will be something like this. So this is pretty straightforward. But whereas the indirect recursion, so this is what it will look like if we had direct recursion and indirect recursion. You see, in the indirect, it calls the other function to do recursive calls. What's the difference between tailed and non-tailed recursion? So recursive function is a tail recursive when the recursive call is the last thing executed by the function. Again, the recursive function is a tail recursive when the recursive call is the last thing executed by the function. Okay, so last point I want to make is how do we allocate memory to different function calls in a recursion? So memory allocation to a different function call. So when any function is called from main, the memory is allocated to on the stack. A recursive function calls itself. The memory for called function is allocated on top of the memory allocated to calling function, and different copy of the local variables is created for each function call. When the base case is reached, the function returns its value to the function by whom it is called, and memory is deallocated and the process continues. So okay, so let's take a look at a problem. So let's say we want to let's say we're working with a triangle. So we're gonna do some geometry. So given an array of integers, given an array okay, so given an array of integers, so we're given integer array, and we want to print the sum triangle from it, such that the first level has all array elements. So let me write this down. From there, at each level, number of elements is one less than the previous level. So again, at each level of elements is one less than the previous level, and elements at the level is the sum of consecutive two elements in the previous level. So let's give you an example. Let's say you have input let's say you have an input of so what's the output going to be? So why is this going to be 48, 28, 20, 28, 8, 12, 16, 5, 3, 5, 7, 9, 1, 2, 3, 4, 5. So why is this going to be this case? Because if you look at the input array, for the very first layer, which is 1, 2, 3, 4, 5, that's just going to be the input. Whereas if you look at the second row, you get 1 plus 2, which is equal to 3. You get 2 plus 3, which is equal to 5. You have 3 plus 4, which is equal to 7. You have 4 plus 5, which is equal to 9. And then again, if you look at 8, 12, 16, you get these numbers because 3 plus 5 equals 8, 5 plus 7 is 12, 7 plus 9 is 16. And then if you look at the next level, 8, 12 is 20, 12 plus 16 is 28. And if you look at the topmost level, it's going to be 28 plus 20, which is 48. So I'm going to give you a hint. The solution can be implemented using recursion. So I'll give you guys 2 to 3 minutes to solve it, and then, or not to solve it, but really to think about it, and then we'll solve it together. Okay, it looks like we got some interesting solutions in the chat section. So one way is to use recursion, and obviously this is what we're trying to implement. And so basically, at each iteration, we create a new array which contains the sum of consecutive elements in the array passed as a parameter. So we make a recursive call and pass a newly created array in the step before. And then lastly, while backtracing, we print the array for printing in the reverse order. So let's take a look at how this would look like. So we can use any language, C++, Python, but let's try with Java. So we have our solution. So obviously, and most importantly, we have to put our base case. So if the array's length is less than 1, we just return. So now we go to the actual content. So we create a new array, which contains the sum of consecutive elements in the array passes as parameter. So we're going to create an integer array called temporary. And then all the way from beginning to the length of the array, we're going to do two operations. Number one, we're going to add up the array at the ith element with array at I plus 1, so consecutive, right? And then in the temporary variable, we're going to replace that I with value. So we are creating a new array which contains the sum of consecutive elements in the array passes as parameter. Next, we make a recursive call and pass the newly created array. Right? Because sum triangle takes in integer array as its parameter. And then the last step is going to be printing the current array at the end so that smaller arrays are actually printed first. This is very important. So the reason we do system.out print line at the last line of this method is so that the smaller arrays are printed first, because it's a recursive call, and whatever is in the deeper recursive tree, that's going to be printed first, and the most top recursive call is going to be printed last. So obviously we have to do main So we've done recursion, and obviously when we're solving for some triangles from array, there's many ways to solve it. And then to get a better understanding of what are the variations and how can we optimize for different use cases, we'll deep dive into more questions. So we've tried array. So it's a good opportunity to tackle maybe a linked list, because we want to always utilize different data structures. Now, here's a question. So you're given a singly linked list. So a simple question: you want to delete a node at the ith position without using a loop. Okay, so what's the input? Let's say you have list of 0, 0, 1, 6, 2, 3, and then you have I equals 3, then the output is going to be 0, 0, 6, 2, 3. Okay, so hint, you can obviously use a recursive method to reduce the value of I. Okay, so I'll give you guys 2 to 3 minutes, and then we'll come back together, solve it. Okay, so we recursively reduce the value of I. The reason we do this is when I reaches 1, we can delete the current node and return the next current node as a new node. So when the function returns, we link the returned node to the next previous node. Again, we reduce recursively the value of I, and when it reaches the 1, we just remove the current node and return the next current node as a new node. And then when the function returns, we can link the return node to the next previous node. So let's write this down using actual code. So here, we're going to need a static class called node. So we're going to have a method that actually deletes the ith node and returns the new header. So if invalid I, we return. So if the linked list is empty, we return null. And then we do the base case. The start needs to be deleted. So we would also, if we were to implement the full thing, we would have to implement all the utility methods and the utility functions, for example, to insert a node at the beginning, a utility function to print a linked list, and a driver program to test the functions. So the summary is we recursively reduced the value of I. And then if, as you can see in this code block, when the I reaches 1, we delete the current node and return the next current node as the new node. So we're like essentially connecting it. And then when the function returns, we link the return node to the next previous node. So also, the delete node, it consists of delete node, push, print list, and then the main driver function. So there's other ways, obviously, to solve this, which is basically deleting the nth node from the end of the given linked list. So it's a very similar question. And the way you delete an nth node from the end of a given linked list is actually pretty similar to this. So the question is, given a linked list and an integer n, the task is to delete the nth node from the end of the given list. So whereas this one was from the beginning. So the problem actually simplifies down to that we have to find the k minus nth node from the beginning, where the k is the total nodes in the linked list, and n is the nth node from the end of the given list. So one way of doing this is to find the length k of the linked list in one pass. Then in the second pass, move k minus n step from the beginning to reach the nth node from the end. So to do it in one pass, we can take the first pointer and move n step from the beginning. Now the first pointer is k minus n steps away from the last node, which is the same number of steps the second pointer requires to move from the beginning to reach the nth node from the end. So here, the approach is that we take two pointers. The first will point to the head of the linked list, and the second will point to the nth node from the beginning. Now we keep incrementing both pointers by one at the same time until the second is pointing to the last node of the linked list. After the operations from this, the first pointer should point to the nth node from the end now. So we just delete the node that the first pointer is pointing to. So how would this look like? Again, same question, deleting from the end. So this method is to delete the nth node from the end of the given linked list. The first pointer will point to the head of the linked list, and the second pointer will point to the nth node from the beginning. So if count of nodes in the given linked list is less than n, so in this case, if the count is equals to n, we just delete the head node, right? This is a simple case. Now we update the second to the next node. Once we're out of this for loop, we increment the both counters by one until the second pointer reaches the end. So it's sort of like a window. And then the first must be pointing to the nth from the end by now, right? Because we shifted all the way to the right. So we delete the node first is pointing to by connecting the first to the next. So I have around 3 to 4 questions that I recommend you to, that I recommend all of you to really take a look, study, and implement. And also maybe test it out in your own IDE or on your own terminal or your code editor. Number one is, and these are fairly straightforward questions. Number one, binary search tree verification. So in this case, given a binary tree, you need to write a method to test if tree is a binary search tree. Another question I want you to do is find permutations of input. Write a method that returns all permutations of a given list. Also, longest consecutive branch in the tree. So given a tree, you need to write a method to find the length of longest branch of nodes in increasing consecutive order. And then the last question I want you to do is reverse a stack. So given a stack, you need to reverse the items without creating any additional data structures. So I want you to try these out before our next sessions, because these are important, fundamental, basic questions in binary and recursive questions in real technical interview setting. Okay, so I wanted to thank you for your attention and participation. Again, if you need assistance with job search, technical interviews, or mentorships, or one-on-one coaching from companies like Microsoft, LinkedIn, Snapchat, IBM, BlackBerry, where I have worked as a software engineer, so HiCounselor could be a great resource for you. The payment structure at HiCounselor is an income share agreement where you don't have to pay anything. So only once you land a job, you pay a small fraction in monthly installments. So there's going to be $0 upfront payment. Feel free to use my referral code Andrew on HiCounselor.com. It is ANDREW. So when you use the referral code, you'll get a $500 discount when you start paying HiCounselor after landing the job. So I want to thank you again, and I'll see you in the next session.